It's your friendly math tutor, Miss C here, and today we are talking about all the possible transformations sine functions can take on, and then we will solve some of these complicated equations. So a lot of times we see transformations explained using the letters A, B, C, and D. You can see that I've color-coded those in this equation. Let's talk about what each of these transformations does to the graph of sine, how we calculate the values, and then we'll do it on an actual problem. So A stands for amplitude. That is the amount of vertical stretch we will see in the sine wave. So it is a factor. That number is always multiplied by the maximum, which is 1, and the minimum, which is -1, to get the new value. But we can't actually talk about maximum and minimums without talking also about the variable identified as D, which is the vertical stretch. So these values together tell you what your maximum and minimum values are on your graph. So the way that you calculate those, the maximum is A plus D, and the minimum is -A, because remember, the sine wave has a minimum in y equals sine of x at -1. So you negate your A value and you add that to D, and that is how you find your max and your min. Now, A is tricky because if A is negative, it doesn't mean the amplitude is negative. Amplitude can only be positive. A negative means that this entire function is reflected over the x-axis. Okay, let's move on to B. So B is the frequency. That's the number of times a complete sine wave happens within the y equals sine of x period, which is 360 degrees. So a period of a function is found by saying 360 degrees divided by B. And that tells us how many times the wave repeats within 360 degrees. Or you could think of B as being the B full waves within 360 degrees. So this is really important when we find values on sine waves, because if our period is anything other than 360, we know that the wave repeats sooner. So for example, if B is 4, we know that our sine wave would repeat 360 divided by 4 degrees, which is 90, which means that we would have repeating y values every 90 degrees. So that increases the number of solutions we have within a given domain. Finally, we have our phase shift. So our phase shift often is represented by the variable c, so it's the one in blue, but it is influenced also by the frequency, because that bx plus c term means that the b has been distributed into the c. So the way we find the phase shift is by saying that the graph is shifted c divided by b degrees to the right if it's positive, and c divided by b degrees to the left if it's negative. Remember, when we're talking phase shift, we're trying to make what's in the parentheses 0. So whatever value B takes on to make that happen is what our phase shift is. Positive shifts right, negative shifts left. All right, let's see this with actual numbers. So here is our equation. Y equals 4 times the sine of 2x plus 90 plus -3. Should really just say -3. I don't know what I was doing there. All right, our amplitude is 4 and our vertical shift is -3. That means our maximum is +1. We just add 4 and -3 together. And our minimum is -7. As a quick check, your amplitude, the distance between your maximum and your minimum should always be double your amplitude, right? So if you think y equals sine of x, the amplitude is 1 because it's not written. The distance between 1 and -1 is 2. So that's true for every other amplitude. So the distance between 1 and -7 is 8. So these are correct maxes and mins. Our frequency is 2. That means we have 2 complete sine waves in 360 degrees. Our period is the 360 degrees divided by 2, so our period is 180 degrees. That means our wave repeats every 180 degrees, and we have 2 full sine waves in 360 degrees. Finally, our horizontal shift, or our phase shift, is 45 degrees because what happens is x has to take on the value of 45, actually negative 45, to make that 0. So we could think that 90 divided by 2 is 45. But since x has to be negative to make what's inside the 0 equal to 0, our graph is shifted left 45 degrees. If you think about it being c divided by b, 90 divided by 2, that's how I got 45. And then you just have to know that you're trying to make what's inside the parentheses 0 to get that shift left. All right, that is all the ways this graph is transformed. And by the way, this is a lot of transformation, and this would be really hard to graph if you were doing this by hand. So if you are, I would suggest that you graph all the transformations except for the frequency change initially, and then you do the frequency change last. That's what I find is easiest. All right, now let's go ahead and solve something that has all of these transformations. This is our first equation that we are solving with 4 transformations. We're going to go ahead and start by identifying all the things that are happening to this graph, because I find that a lot of teachers want to know that you know that. So in this particular graph, I noticed that I have an amplitude, as we just talked about on the prior screen. That's this number right here of 6. So I'm going to write 6, and our vertical shift is this number right here. Make sure that you don't drop the negative, because that's really important. So when we look at this, we know that our new maximum, if we just had amplitude, is 6, and then it's shifted down 4. So it's going to be 6 minus 4. So our new maximum is negative 2. And our new minimum is, we would normally have negative 6, right? Because remember, the minimum of our normal sine wave is negative 1. So we times it by 6 to get negative 6. And then that value is shifted down 4. So that gives us negative 10. So our new max and mins are negative 2 and negative 10 respectively. Our frequency is this number right here. So that's 3. And our period is 360 divided by 3, which gives us 120. So that means that our graph, this is the very, very important number here, that our graph repeats every 120 degrees. And that means every y value also repeats every 120 degrees. And then our phase shift is the combination of our frequency and that minus 180 degrees. So one of the ways you can find this is by doing this. You're trying to make what's inside the parentheses 0. So I'm just going to go ahead and solve this equation, adding 180 to both sides. And when I do that, I get x equals 60. That's a positive number. That means our graph is shifted to the right 60 degrees. Okay, so now that we've explained all the transformations, let's get to solving this. One of the important things we're going to see here is that we have a domain of 0 to 360. I'm going to also highlight over here, our period is 120 degrees. That's going to be really important when we are solving this equation. When we're finding our values at the very end after we solve this equation. So let's go ahead and get to it. I'm going to go ahead and try to get sine of 3x minus 180 degrees by itself. So I'm going to follow the order of operations in order to do that. I'm adding 4 to both sides. That gives me sine of 3x minus 180 equals 0.64. Okay. And now I'm going to divide by 6 on both sides to get sine of 3x minus 180 by itself. When I do that, I get 0.11. So I'm choosing to round to the hundredths place. Of course, do whatever your teacher suggests you should be doing in terms of rounding. All right, now I'm going to go ahead and take the inverse sine of both sides. I'm not going to write that out because it makes it really long. When you take the inverse sine of the left side, you are left with what's in parentheses. When I take the inverse sine of the right side, I'm going to write this so you can see what I mean when I say inverse sine. This is what I already did to the other side. I'm taking, that's the inverse sine. There's a button on your calculator, so go ahead and click that and then put in 0.11. And what you're going to get is 6.12, and this is degrees. As a reminder, double check that your calculator's in degree mode. If it is not, if it's in radian mode, you're going to get a number other than 6.12. So double check that before you solve every problem so you're in the right mode. Okay, at this point, I'm going to come over here and I'm going to use my property that says that within 180 degrees, I will have a second sine value. And what I do by that is I essentially write the left side of the equation and it's equal to 180 less 6.12. So that's going to be my second equation that gets us the second set of symmetrical values. I'm going to work the left side of my problem first. So I'm going to add 180 degrees to both sides. When I do that, I get 3x equals 186.12 degrees. And then I'm going to isolate x or get x by itself by dividing by 3. When I do that, I end up with 62.04 degrees, and this is one of my answers. It falls within my domain, so that works. Now, I know that this value repeats on the next sine wave every 120 degrees. That is our period. So now I'm going to just add 120. If my domain was to negative 360 degrees, I would also be deducting 120. But since I'm only looking for positive values, I'm adding those. So when I do that, I get 182.4 degrees. Okay, I'm going to add it one more time because I think I'm going to have another value that is within domain. So 120 gets added there. And then I find that x equals 302.04 degrees. So those are the three values on that side. You can check to add 120 one more time. If I do that, I'm definitely going to be beyond 360 degrees. So that's why I'm choosing to stop here. So those are the three values on the right side. And now I'm going to go ahead and find the three values for this equation. So the first thing I'm going to do is I'm going to simplify the right side of my equation. When I do that, I get 173 degrees, 173.9, 0.88 degrees, pardon me. Okay, and now I'm going to go ahead and solve for x by adding 180 degrees to both sides. When I do that, I get 3x equals 353.88 degrees. And now I'm going to isolate x by dividing by 3 on both sides. And I get 117.95 degrees. That value falls within our domain. So that works. And now I'm just going to apply the period change here. So I'm going to add 120 degrees to get my next value, which is 237.96 degrees. And you guessed it, I'm going to go ahead and do that one more time. And when I do that, I get x equals 357.96 degrees. There we go. It looks like I rounded incorrectly here, so this should be a 6. Pardon me there. All right, I went ahead and checked all of these answers in my calculator. The way that you would do that is if I scroll back up to my very top equation, I'm going to put this entire part, Let's try that again. I'm going to put this entire part in my calculator, and where I see X, I'm going to replace that with my answer every single time. So remember, on most calculators, you can use the back button to duplicate the equation or go back up to the equation before, and then you can just keep replacing that X and hitting enter over and over, and it's a fast way to check. I checked all 6 of my answers and they were all correct. I got approximately negative 3.36, and I say approximately because I rounded my final answer, so it's not going to be exact. All right, let's do another problem. All right, we have our next example. We're going to go through this a little bit faster. So our amplitude here is 3, and our vertical shift is 5. As a reminder, we add these together to get our maximum, which is 8. Our minimum on a normal sine wave is -1. When we have an amplitude of 3, it's -1 times 3 gives us what it would be, our amplitude would be without a vertical shift. So that gives me -3, and now I'm shifting that value up 5, so that gives me 2. So as a double check, my amplitude together should create a distance between the maximum and minimum point of 6, right? You double the amplitude. And my max and min have a distance of 6. So that's a great check to do. My frequency is half. That means my period is 100, or not 180, 720 degrees. So 360 degrees divided by the frequency gives you your period. And then our phase shift. So I like to do this in my head. I'm looking at what makes what's inside the parentheses 0. I did it algebraically on the last video. I'm going to do it in my head. I know that theta has to take on a value of -200 to make what's inside the parentheses 0, right? Because -200 divided by 2 is -100. -100 plus 100 is 0. Negative numbers move our graph to the left. In this case, left 100 degrees. So this is massive transformation. All right, let's get solving now that we know that all the things that have happened in our graph. So we have a domain from 0 to 1080 degrees. It's a big domain. I know that as a first step, I'm going to try to get the sign of whatever's in the parentheses every single time by itself. So I'm going to do that by subtracting 5 from both sides. And when I do that, I am left with 3 times the sine of half theta plus 100 equals 2.84. And now I am continuing trying to get that sine of its parentheses by itself. So I'm dividing by 3. All right, so on this side, I'm now left with sine of half theta plus 100. And that equals 0.95. I'm rounding to the hundredths place. Make sure you round the way that your teacher asks you to round. Okay, and now I'm going to do the inverse sine of both sides. I'm not going to write this because it takes up a lot of space, and I've done it in every video. When I do that, I'm left with half of theta plus 100 equals 71.2 degrees. On the opposite, the symmetrical value, I am going to say that I have half of theta plus 100 equals 180. This is our symmetry minus 71.2. So we always use the value that we found when we took the arc sine of that value. Okay, now I'm just going to simplify the left side. So I'm subtracting 100 from both sides. When I do that, I get half of theta equals negative 28.8 degrees. Okay, and I'm going to slide my screen up a little bit. Oh, I don't know where that came from. Okay, all right, and now I am going to get theta by itself. I'm choosing to multiply by 2 to get rid of my fraction. You, of course, could divide by half. Personal preference here. When I do that, I get negative 57.6 degrees. And that solution is a very valid solution, but it is not in our domain, so it's not one of our answers. So it is a solution on this graph, but we're just going to say it's not a solution for us. Okay, now I'm going to add 720 degrees to this because my domain is 0 to 1080 degrees, and I know that if I add 720 degrees, I am going to be within domain. That gives me 662.41 degrees. If I add 720 degrees, again, I'm going to be outside of domain. So we're going to leave it just like that. Okay, I'm going to pop over to my red equation now, and I'm going to work that. So I'm going to simplify the left side or the right side of the equation. And when I do that, I get 108.8 degrees. And now I'm going to subtract 100. And that gives me half theta equals 8.8 degrees. And I'm going to multiply by 2 to get rid of my half. So again, you could divide by 2, and I'm going to get 17.9 degrees when I do that. And that is within our domain. So this is a solution. Okay. And I'm going to add 720 degrees. You could also subtract 720 degrees, but I know that when I do that, I'm going to be outside of my domain. So I'm just adding on purpose. Oops, and this should have been a 5.9. Sorry about that, 5.9 degrees. Okay, that is within domain. If I add 720 again, I'm going to be outside of domain. So my 3 solutions within our domain are right here. I plugged those into my calculator to make sure that I got out approximately 7.84, which I did. And you should always check your answer too. All right, next problem. Okay, our final problem. Let's go ahead and go through this really quickly. Our amplitude is 1/4. It is not negative 1/4. We'll get there in a second. We have a vertical shift of -7. That places our maximum at 6 and -6 3/4, and our minimum at -7 and 1/4. Okay, I've explained how to do this throughout this video, so I'm not going to go into how I got those values. We also have a reflection about the x-axis. That's what this negative number is. So basically, every negative value becomes positive. Every positive value becomes negative. So that doesn't change our max or min. It just changes where they're located. And then our frequency is 2. That means our period is 360 degrees divided by 2, which is 180 degrees. So this is going to be really important for us. And our phase shift, if I figure out what alpha has to be within the parentheses to make what's in the parentheses 0, I get 30 degrees. 30 is positive. Positive moves our graph to the right 30 degrees. Okay. All right, let's go ahead and get solving. As a reminder, our domain is -360 degrees to +360 degrees. And our first goal is to get that sine of 2 alpha minus 60 by itself. So we're going to do that by adding 7 to both sides as a start. When we do that, we get -1/4. Having trouble writing here. Let's try that again. -1/4 times the sine of 2 alpha minus 60 equals negative point. I'm just doing great right now. Negative 0.14. Okay, and now I'm going to get rid of my -1/4. You can do that by dividing by -1/4, or as you know, I prefer to always multiply by the reciprocal. Just don't drop your negative there. So I'm going to end up with sine of 2 alpha minus 60 equals 0.56. Okay, at this point, I'm going to take the arc sine of both sides. And when I do that, I get left with what is in the parentheses. And the arc sine of 0.56 is 34.06. Okay, now I'm going to go ahead and come over here and write my parallel equation that says that we have 2 values on a sine wave within 180 degrees. So I'm going to say 180 degrees less the value I just found by taking the arc sine of this number. So 34.06. Okay, I'm popping back over to the other equation, and I'm going to go ahead and solve for alpha. I'm adding 60 to both sides. When I do that, I get 2 alpha equals 94.06 degrees. And now I'm dividing by 2. And when I do that, I get alpha equals 47.03 degrees. Good news, this is within our domain, so this is one of our solutions. All right, the next solution we're going to find we do by adding 180 degrees because that's our period. When we do that, that gives us 227.03 degrees. Also a solution. If I add 180 degrees again, I'm going to be over domain, so I'm not going to do that. But what I am going to do is I'm going to come back up to our original value and deduct 180 because I'm going all the way to negative 360 degrees. And when I do that, I end up with a value within our domain, which is negative 132.97 degrees. That's within domain. And I actually think if I deduct 180 degrees again, I'm going to get yet another value within our domain. And that is true. I end up with negative 312.97. If you're skeptical, I would always just urge you to check that your value is not outside of the domain just by doing a simple calculation. That'll save you some errors. I'm coming over to simplify the right side of this equation and then solve for alpha here. When I do that, I get 145.94 degrees. That took me a second. Okay, and now I'm adding 60 to both sides. That gives me 2 alpha equals 205.94 degrees. Dividing by 2 to get alpha by itself. And when I do that, I end up with 102.97 degrees. Okay, that solution is within our domain. I'm going to go ahead and add 180 degrees to that because I know I'm going to get another value within our domain. And when I do that, I get 282.97 degrees. These are both within our domain. If I were to continue doing what I'm doing, I would get, if I added 180 degrees again, I'm going to get a value outside of our domain. So I'm going to subtract now. Oops, I'm not going to subtract there. I'm going to come up to my original value and I'm going to subtract 180 degrees. Come down here. And when I subtract 180 degrees from 102.97, I get negative 77.03 degrees. That's a solution. And then I'm going to subtract 180 degrees one more time because I do believe I'm going to get a value within domain again. And I, in fact, do. I get 257 degrees. 257.03 degrees negative. Okay. All right. So we have 8 solutions. And I decided for this last problem to pop the graph on so that you can see, and you can see it's shifted so far down. My values are up top and I wrote over the top of those. So let's look at our initial. We started out with 47.03 degrees. So here's the deal. I'm going to go ahead and circle where we have solutions. So I put the line of y equals negative 7.14 in blue and our sine wave is in red. So we've got 1, 2, 3, 4 solutions in the positive realm, which is what we have. And we have 1, 2, 3, 4 solutions in the negative realm. So this value is the first value we found, that negative 47.03. And this value right here is like slightly bigger than 100. And this is its value here. Remember how we talked about, I'm going to do this, these two guys, how we talked about having two values within 180 degrees. That is what we got here. So now if we take the first value that we had, this one, and we add 180 degrees to it, we end up with our first value slightly bigger than 200, which is this guy. And then if we took this second value right here and added 180 degrees, we end up with a value that's just shy of 300, So our 282 degree value, which is right here. Okay, and now if we come back to these two values and we start deducting, we end up with all of these values, right? Okay, and that's why when we solve in this way, it's why it works from a graphical standpoint. All right, thanks for taking the time to solve this very complicated equation with me. Make sure to subscribe for more math videos. Till next time, remember, you've got this.